Science Made Simple with Mr. Sani.
We want to look at the meaning of scalar and vector quantities. By now, I think you know the meaning of quantity. So, let me see scalar quantity. Scalar quantity are quantity that has magnitude only, but no direction. While vector quantity has both magnitude and direction. So, example of scalar quantity. We have our mass, length, speed, and so on and so forth. While in the vector quantity, we have velocity, acceleration, pressure, and so on and so forth. So, scalar quantity has no direction, only the magnitude only. While vector quantity has both magnitude and direction. What do you mean by the position of an object? The position of an object is the location of the object in the region, in the Earth region, or the location of an object in the space. If you want to locate an object in the space, you have to know the two crosses, two lines like this. This one is called vertical line or y-axis. While this one is called the horizontal line or s-axis. This middle point is called where the two axes meet each other. That one is called the origin. That is, this is the origin. We have here as positive s. If it go like this, negative s, like this, positive y, like this, negative y. If you want to locate an object in the region, you draw these two axes that are called the x and y axis. Let's say this x-axis is graduated 1, 2, 3, 4, 5, and so on. For this side, we have -1, -2, -3, -4, -5. You know, I told you this is positive x. This is x-axis. This is negative x. Ditto to this axis. You can also say this place is 1, 2, 3, 4, 5, 6, and so on and so forth. This is y-axis. Y-axis. For the down, we can have -1, -2, -3, -4, -5, -6. If you want to locate the position of, let's say this is our A, point A, in this region, point A, you first write it, the value of the position of A in x-axis, before you write the value of the position of A in y-axis. That is, you are going to follow this format. Write the value of A in the x-axis and the value of A in the y-axis. For A now, let's say this position A, you trace A down. A here, the value of A here is 1 for the x-axis. We trace it down to the y-axis, the value is 2. That's A now will now be in bracket of 1, 2. That is, the position of A is 1 and 2. Another one is, let's say this place is our B. Let's say we have our B here. Our B here. To write the value for B, we trace B here to S. That is 3. B is in 3 on x-axis. And on y-axis, B is 6. So to locate B be 3, C. That's the position of the B. Let's say we have C here. Let's say this is our C. So the same thing, our C here, you have C here, you treat this one, that'll be minus 5. Then come to this side, that is 6. Position of C is minus 5 and C. Let's say we have D. Let's say we have D here. D here. D be 3 for x-axis and minus 3 for the y-axis. This is how to locate the position. But we might also ask to calculate the distance between AB. Look at it now. Distance between AB. The distance between here and here. So I want to see this. You can join this line to make this line. So our distance AB, we have triangle of ABC. Triangle ABC. So this triangle now has formed what is called right angle triangle. Right angle triangle. We have our A here, B here, C here. To calculate the distance between A and B. That means for this distance, for here now we have our B to be minus 6. Distance between that be, to get here now, to get BC, the value for B here is 6 minus the value here for the C is 2 minus 2. All over, the value for this place, we want to want to get the distance between A and C. Here you have 3, C is 3 here, and A is 1 here. That is, from here to here is 2. From here to here is 4. 6 minus 2 for a vertical axis will give you 4. 3 minus 1 for horizontal will give you 2. That is from here. That is, we have our AB here. AB here is, so this right angle triangle now, you can use Pythagoras theorem to get AB. From Pythagoras theorem, we have our AB square is equal to BC square plus AC square. That is the square of this side. Pythagoras theorem. Hypotenuse square, that's our AB, is equal to AB square, opposite side, this angle theta, and adjacent square, that is Pythagoras theorem. Hypotenuse square is equal to opposite square plus adjacent square. So from here, you can see that our hypotenuse, that is AB square, is equal to opposite square. 4 is opposite this angle. 4 square plus 2 square. 2 is adjacent. 4 square is 16. 2 square is 4. That will be 16 plus 4. That is 20. So then our AB now, AB will now be the square root of 20. So that is how to calculate it. So that we have scalar quantity and vector quantity. And I said that speed is distance over time, while velocity is displacement over time. You see, distance and displacement, they are virtually the same thing. But displacement is distance in a specified direction. Before we can say this in displacement, it must be distance in a specified direction. That is, it must have both magnitude and direction. Displacement has magnitude and direction, while distance only has magnitude. So now, in the last session, we said we have our AB like this. We calculate our AB to be square root of 20. That square root of 20 is the magnitude for AB. But what is the direction of AB? To know the direction of AB, we are going to make use of our 4 cardinal points. The north, south, instead of having this one as vertical line or y-axis, we have it as This place is north, this place is south. That one is representing our vertical axis. While this one is representing our, we have our west, east, representing our horizontal axis. West here, east here. This is 4 cardinal points. We make reference to the north. That is the starting point. So any angle we measure from here, this place is 90 degrees, 180, 270, 300. That's the bearing. That is the angle in a point is 360 degrees. So if we have from this one, if we have the distance in this direction, you can say our AB. If we have our AB here like this, you can say our AB in eastern direction, or our AB in western, in northern direction. If you go like this, our AB in western direction, this place is our AB is in southern direction. But this is how we have our AB. You can see our AB now. See our AB. AB. We put the direction. It's different from distance now. This arrow represents the direction of AB. So our AB here, our AB, AB. You can say here is north, east. Middle point of here you can say east, south. Middle here you can say west, south. You can say north, west. So we can say here now that our AB is in northeast direction. Northeast direction. Yeah, our AB. But we can also calculate the value for the angle theta of our AB. You know, in the previous section we have it that this our AB, we call this one C. This our ABC is now a right angle triangle. From where we get our BC to be 4 and AC to be 2. And this one is square root of 20. And this is the angles of the AB. Angles sustained by the triangle, that is AB. So we can calculate this, the value of theta from this triangle. This is a right angle triangle. To calculate the side, we make use of the hypotenuse theorem. But now we want to calculate the angle. We are not going to use hypotenuse theorem again. We are going to use what is called SOHCAHTOA. SOHCAHTOA. This SOHCAHTOA is used in relation to right angle triangle. That you can only use it for right angle triangle. You can't use it if the triangle is not right angle triangle. Just note, you can't apply it to all triangles. You can only apply it to a right angle triangle. This S here means sine. Sine is equal to opposite h over hypotenuse. That is so car. Now car is cos theta is equal to adjacent over hypotenuse. That's the second. The last one, tua, which is tan theta is equal to opposite over adjacent. This is the meaning of SOHCAHTOA. Now, if you look at where we are coming from, our triangle now. This is the right angle triangle. We have our theta here. This side BC is opposite to this theta. You have to be very, very careful about the opposite side to the angle. You know that the longest side of a triangle is hypotenuse. But the two sides, the two remaining sides, we have to be, before we can say one side is opposite, we have to be mindful about the angle. Now, this angle theta here, the side opposite angle theta here is BC. While the side adjacent angle theta here is AC. You can see this side is opposite here. This side, where the angle lies on, is the adjacent side. So now, you want to calculate tan theta here now. We can make use of, because we are giving opposite and adjacent. You now look at which formula can we apply. We have opposite to be 4 and adjacent to be 2, adjacent to be 2. So we will now look at the Socrates. Which formula connect opposite and adjacent? You can see that it is tan. So our tan theta is equal to 4/2. This tan theta is the same thing as slope. This is what we are calculating when we say calculate the slope of the graph. We are calculating tan theta. Tan theta is the same thing as slope. So this slope is also it's called dy dx. I will say slope is also called dy y2 minus y1 over s2 minus s1. In the previous example, we have our slope. Our dy is to be 4/2. So our tan theta is equal to 4/2. Our theta now, make theta subject of is equal to tan inverse of 4/2. I think you can answer, you can get the answer. Tan 4/2 is 2. Tan inverse of 2. Whatever you get is our theta. So that is the how to get the angles obtained by the distance. So now we can say our AB now, the distance for AB is square root of 2, while the direction for the AB is tan inverse of 2. So you combine these things together. Let's say our AB, what's the value for square root of 20? What's the value for square root of what's the square root of tan inverse of 2? So our AB will now be something like 4 point something in so direction. So that means our AB, we have gotten direction for the AB. So that makes it displacement different from the distance. Thank you.